Well, thank you all for coming this afternoon. Welcome to Harnessing the Power of Data for Sustainability and Grid Modernization. Everyone having a good reInvent? Tired? Yeah. Thank you for coming, really appreciate it. My name is Elena Bookstein. I run corporate development for AWS Energy. I'm going to talk through a little bit about how AWS Energy thinks about driving the decarbonization journey and the modern grid. And then I'm going to introduce one of our lighthouse partners, NextEra, who's going to talk through a use case about harnessing analytics around grid modernization and decarbonization. Thank you for coming, and I am going to dive in. We believe that cloud technologies are foundational to decarbonization. Going forward, we see the energy mix rapidly changing, and increasingly flexible technologies will be part of the grid and represent up to 32% by 2035 and 50% by 2050. And if you think about all that flexible capacity and distributed assets, the need for better energy insights and a modern grid becomes instrumental. You can also think about technologies like carbon capture and nuclear, who, if we cannot permit and grow our renewable energy portfolio quickly enough, these assets will also become part of the core base load and variable load and will require more analytics and more integration. Meanwhile, millennials, who are really driving the prosumer generation, are changing expectations for how energy companies serve their customers. There's great statistics that about 44% of millennials are thinking about solar and electric vehicles compared to the mature generation that basically says we'll never try solar at about 44%. So we've got a tremendous amount of change in the energy system on both the grid operator as well as the producer side of the equation. And we believe digital is going to be a critical part of driving that change. The digital technologies that are going to make a difference are going to be those driven by technologies that directly impact the climate or enable or accelerate or even debottleneck the energy transition. According to Accenture, 78% of energy providers say that those who do not help their customers achieve net zero with greener products and services will get left behind. And core to those enabling applications are cloud services like advanced analytics, AI, ML, high-performance computing, and edge computing. And we think about those cloud services as directly having impact on our energy customers' ability to meet the needs to increase energy production, lower costs, reduce carbon intensity, and manage risk. And we work together with our customers on how we can solve these biggest problems, bringing the best technology to the table in a time of incredible uncertainty. So it's a great time to be in the business. What specifically will the cloud enable around digital innovation for the modern grid? The way I think about it, the next generation of the energy grid needs innovation in both infrastructure and the digital components of the grid if we're going to ensure effective delivery and solve industry challenges. The digital technologies are critical because the modern grid is going to be resilient. It's going to be able to handle critical events, including increasingly volatile climate and weather. The modern grid is going to be responsive, able to sense and adapt in real time and deal with unexpected changes in the operating environment. The modern grid is going to be resourceful, able to make the most of every existing asset. It will be reliable, able to continue doing all of this on a massive scale, and it will be renewable. So there's no small task around the modern grid and how we serve the needs of the changing energy environment. What is AWS for energy? AWS for energy, we like to think about ourselves as accelerating the energy transition for customers through practical innovations that enable organizations to hit their most important KPIs. So if we're not doing work that helps drive the bottom line, that drives increased renewable or increased energy production to meet the needs of our customers, driving efficiency, driving reliability, managing risk, then we're not doing our jobs. We bring together the most advanced and secure cloud services with deep energy experience across energy, utilities, and the renewable energy sectors. We also leverage the broadest energy partner ecosystem to empower energy leaders to transform their business. So think about ISVs and SIs that we can work together to really solve the energy leaders' biggest problems today. It's a privilege to serve what I consider the most strategic lighthouse energy customers across the globe, whether it's Shell and BP and Phillips 66 to Iberdrola and Ørsted. We have the privilege of working on some of the hardest problems in the energy sector with some of the most impressive leaders to date. And again, we're focusing on what we see as the most critical needs in the industry, and are continually excited about customers bringing us new challenges that we can work on together. To give one example, I'm going to introduce one of our strategic partners, NextEra Energy, who's going to talk about specifically harnessing data for the modern grid and to drive decarbonization. I'd like to introduce Joshua first. Yes? No, okay, so introduce Milan Dave, Senior Director of Commercial and Industrial Origination for NextEra, where he is tasked with creating the zero carbon blueprint for the Fortune 1000. And Joshua Gary, who's also going to join. He's a Director of Enterprise Data for NextEra Energy, where he specializes in building data-first solutions to solve operational problems using the best technologies, not just the newest, to create operational efficiencies and allow organizations to be more profitable.
Thank you.
Coming up. Great.
All right, well, fantastic. Thank you for the introduction, and welcome everybody to this session. Thank you so much for not only traveling the miles that you did to get here, but more importantly, for deciding not to go to whatever happy hour session you could have gone to at 5 p.m. this evening and hearing us speak instead. Thank you. So we've got what I would like to say, quite an interesting discussion today to share with you. There are a couple of key areas that I'm going to be talking about, and using some terms too. I'm going to talk about megawatts. I think a lot of you know what megawatts truly are. I'm going to talk about gigawatts. I might talk about a power purchase agreement, a PPA. So just keep in mind, I'm going to be using some of those terms as we go through this. Additionally, I am also going to be talking about 3 particular modes of generation. I'm going to talk about solar, a little bit about wind, and also about battery as well. Because what we're doing today, and practically all of this is built on AWS, is we're using data to be able to squeeze the best results that we can for the commercial industrial side. And by doing that, we're able to actually have the best project available for those organizations, so it is economic. So that'll be the story that we go through, and then Josh is going to really hit us very specifically on the rigor and the discipline that we have to use across enterprise data to actually make this successful. And just in addition to speaking all that, I've brought my partner in crime, Dr. Chris Nunnally. He is one of the pioneers that we have in our organization who's developed a lot of our in-house algorithms too, and also have moved some of those algorithms to the AWS side and has demonstrated some of these key results that you'll get to see today. So as we get into the content, I want to point out that we as a collective, we're definitely at an inflection point when it comes to the climate itself. I think a lot of us have probably seen this past summer was pretty warm. It was really hot. If you look at August of 2023, it was the hottest month we've ever had on record. And then the second hottest month was the month before that. It was July. So incredibly warm. So it's really in our best interest to figure out a way to decarbonize. And by the way, if I say decarbonize a bunch of times, we'll make it a drinking game because it is happy hour time for everybody here. So let's dig into this a little bit further. A quick snapshot about NextEra Energy. We are a Fortune 200 company, about 21 billion in revenue. But more interestingly than the revenue and the size of the organization is the number of gigawatts that we have in operation. 67 gigawatts in operation today. And NextEra is broken up primarily in two organizations. We have NextEra Energy Resources, which I'm a part of, and we have FPL, one of the biggest regulated utilities in the US. Close to probably about really realistic 6 million customers today. I think the slide might show 5.8, but close to 6 million. And if I go back to the NextEra Energy Resources side, there are about 34, probably by the end of this year, definitely north of that, close to 40 gigawatts of generation going on. So it's growing every year. It's a fantastic story to say. And all of this really just can't be possible through the way we use data and the multi-dimensional challenges that we're faced with to actually make that happen. And one of the interesting pieces of NextEra is that we have had to look inward before we started to look outward to decarbonize everybody else. It's essentially saying, well, look, we got to practice what we preach, and we've started to do that. So our own business, we have looked at decarbonizing ourselves. We have our own goal by 2045, particularly for our own utility, to make that zero, net zero. And not only have we learned a lot by just focusing on our own decarbonization goals and aspirations. In fact, one of the great pieces about this is that we have a green hydrogen plant. For those of you that know what green hydrogen is all about, that's coming online here very soon. We then needed to start focusing on the power sector itself, the US power sector, and that's really where we're focused into. And that's where NextEra Energy Resources, combined certainly with the FPL side, we work with a number of utilities. Just a quick show of hands, who here is from some of the utilities, if anybody? Yeah, okay, good, I see some. So we work with a lot with some of the utilities to help them with their, not only just traditional generation targets, but renewable generation targets quite a bit. And then we started to look over the past few years, like how do we actually take it a step further and decarbonize the US economy? We've had all these lessons learned thus far, and so now we're thinking, wait a minute, how can we help the larger commercial industrial side? And sometimes I say C&I for short here. And so we started thinking, all right, how can we actually make this happen? And we needed to understand, what does the US economy look like across the different industries? Where are they challenged right now? And I'm saying this information really to help you understand the challenge that is ahead of us to help truly reduce emissions across the US economy. Now, in the top green bar that you see there, that's the power sector, the utilities sector. We, as a collective utilities group, have been able to reduce our own emissions since 2006 by over 35%. So we're doing a pretty good job. And if you look at states like California, if you look at Florida, if you look at down the Midwest, if you look at Texas, there are a ton of renewable generation initiatives taking place there. So it's moving quite nicely. But some of the other industries, they're a little bit, they're making progress. They're doing a good job, but there's still more work, quite a bit of work to be done here. And part of that work was a lot of these companies, and especially in just the past few years, have said, hey, we got to set out some goals. I think many of us in the room have even heard shareholder pressure. We've heard internal employees, internal stakeholders within that organization say, hey, we need to reduce our emissions. We got to have a cleaner footprint. How can we start doing that? And so a lot of companies in the past few years have said, here are our goals. We've stated our goals. We're going to hit a 2030 target. We're going to hit a 2040, 2045 target. They may be even aligned to science-based targets to try and reduce their emissions. That's great. You can see there's over 170% increase in just companies setting targets. Well, you can set a target, and then what? You can measure it, great. But the big deal is executing, being able to execute on those targets and actually start to put projects into place to make it successful. And there are a variety of ways to make that happen. This, what you're seeing, is really a snapshot of different types of solutions we can use to make emissions go down. And I'm not going to talk to each one, but I want you to get a sense. There's certainly the large grid scale component. We sometimes call it utility scale, grid scale. These are the massive 100 to 800 megawatt size projects. It could be solar, it could be wind, that sit sometimes out in the middle of nowhere. Maybe it just powers a data center, maybe it's powering a giant refinery, for instance. Or it could be over on the hydrogen side, or it could be something that's built on site, on roofs. So there's a variety of different tools that we can use to help with reducing cost, to help reduce risk, even build resiliency for that organization, and at the end of the day, just really reduce emissions is what we're trying to achieve here for folks. So taking this type of information that support these solutions is not an easy task. I think many of you here today work definitely probably in a data capacity and understand the challenges of trying to build certain algorithms so that it makes it easier for an organization to decarbonize themselves. And so we're really at a point where it says, we all know that it is very complex to try and reduce our emissions. And each organization that we work with on the commercial industrial side needs a specific tailored approach. So imagine if I'm working with like a major oil and gas company and they have a refining business and they want to reduce their emissions, we got to go look through their entire supply and value chain to figure out at what points can we reduce emissions for them. Is it going to be the scope 1 bucket? Is it going to be the scope 2 bucket? And then there's the ambiguous, the scope 3 component, which is, we don't want to talk about that right now because that is gnarly. So how do we use the data to actually create these tailored journeys? Let's take a step back and look at it from a philosophical perspective first, because every advancement that we've had, and I think many of you realize this, is that there's a major component of it. One, having trusted data. Organizations need to trust the data to actually make the decision, right? It's almost a cliche thing that we hear all the time. But there's also the notion of increased resolution. We've seen it across science for hundreds of years. There's the astronomy side, there's the particle physics component of it, there's the microbiology side of it all. And that gives us a better perspective at a more granular level of what we need to change, what we need to perhaps improve from, or just generally learn from. And that's how we've applied that same philosophy and into some simulations that I'll actually show you as to what we've done at NextEra. So when we start to look at building a model that allows us to perhaps simulate solar or wind or maybe even battery, there are a variety of different attributes we have to consider. And I know for a fact a lot of you work on this piece quite a bit. We could look at weather, of course, is a big component that we go through. We could look at geography, topography. We could look at just the politics of a particular area, the land and the leasing capabilities of a particular area. So all of that is pretty difficult to try and integrate. And there is an interesting study that was just recently done where we did it in conjunction. About 88% of organizations that are looking to decarbonize have difficulty integrating all that data. And then of that 88%, 91% of them really can't measure their entire scope of emissions. So what does that tell us? That, hey, our scope 2 emissions is our best guess, perhaps? Not all the time, because carbon accounting is certainly pretty rigorous in itself, but it is quite a difficult thing to really put your finger on. So there is a challenge, and that is partially why, and really truly why, we have an enterprise data approach to this, and this is where Josh is going to speak a little bit more to it. But I think what I'd like to do now is show you some of the models that we have used at NextEra. And one of them is around what we've now called generation entitlement. We call it Gen E for short. It was an in-house algorithm that we built. It's a fantastic view into how we look at data. In this example, we've got 20 billion data points piling in all the time, and we're analyzing that data consistently. It's really a little bit over 30 gigawatts in installed capacity that we're bringing in through this algorithm, and what it's doing, it's running an analysis of all these projects. And we're trying to learn from it by trying to figure out, okay, what is the performance of this particular project? Is it going to be reliable? Can we learn something better in the future? And so what I'm playing for you right now on screen is a model. It's a visual simulation of looking at a solar farm. It's got different colors, but you'll see those are clouds floating over a solar field over there. It tells us, wait a second, some of those panels are working, some of them are out of commission. Maybe we have optimal megawatt output coming from that solar farm, maybe we don't. It also informs us that, wait a second, do we have shadows in an area where we should have not put those solar panels? Because what this is going to tell us that if a customer is using this solar farm and they had an expected output and they're not getting it, well, we have to change our design in the future to do that. But one of the very interesting points coming out of this is that the industry typically uses what's known as essentially hour-based modeling. And this algorithm really went down to the minute level ability. So using minute level analysis of a particular solar field gave us that kind of data, the ability to see at any particular moment what's happening with that particular project. And all of this has, luckily enough, been able to be built on the AWS platform itself. We used to have it on premise, and I'll get to that part later, what that was like. But now we can run these simulations in a beautiful way. It's just much faster, much smoother process for us. Because what I particularly like to do is I'll take this simulation, and I will go to a C&I customer, a commercial industrial customer, and I will show them that, hey, here's this particular project that functioned like with the certain clouds, maybe with weather patterns, in a particular area where they're interested in, so that they could actually see what that project could look like for them in the future. So it helps tremendously. And so another interesting piece that should be also talked about is how do we actually develop then solar when we're trying to use all this data that we've got? Let's say, for example, you have 1,000 acres. You've got 1,000 acres and you want to squeeze every megawatt that you can coming out of it. Because you know that there is economics tied to that particular project. And it's basically a function of three components here. We're looking at market price, we're looking at cost, and we're looking at energy yield. So we know we got 1,000 acres. I can run this simulation, and what it's doing, it's actually bringing in about 100,000 design combinations. And it's running through every cycle of how we could actually put the panel, the DC size, I'm looking at the rack, I'm looking at the tilt, I'm looking at the spacing, actually also looking at the technology of the solar to use. And it's just brilliant. It's automatically calculating for me how the solar field should look. So if I've got 1,000 acres, I'm trying to squeeze every bit I can. And it's not only taking the land from a two-dimensional perspective, it's using three-dimensional thought processes here to look at, is it sandy? Is it swamp? Is it environmental challenges over there? Is there an endangered frog perhaps in that area that we need to consider? But this gives us all those answers right away. And I can get 200 megawatts out of this particular plot of land, which is ideal, especially for 1,000 acres. That would be great to get that. Now, I'm going to show you a different example. A little bit more complex. Wind. So if you know anything about wind, it spans about 10 to 20 miles across. And now what you're looking in the simulation is we've got red chunks that says, don't touch that area. Those are landowners say, hey, don't mess with us. We don't want that over here. All right. So how do we tie a giant wind farm that's about 10 to 20 miles across with the right interconnection, with the right lines to connect one another? Well, I run the same simulation on the platform as well. And what this is doing, it's building trusted data for that particular customer so they know that they're going to get the best product. So when I'm out there and we're going to start building that wind farm, they can exactly see where all those wind turbines are going to be located. And compared to a solar field, wind fields have about 10 to 30,000 obstacles. And the big thing is, where's the wind going to blow? So I got to start to figure out what are the ideal locations to actually put the turbine? Am I going to put it higher up on the hill? Am I going to put it in a valley, maybe where the wind's blowing all the time? So these are different elements that we have to look at. And so wind itself is an entirely different complex animal. And here what you'll see is I'm taking millions of data points at this point in time. I'm bringing it in through our algorithm, and before, it used to take me 4 to 5 weeks to put out a simulation with an on-premise solution. Now it takes me a day. I got this in 24 hours. I mean, this is amazing to be able to do this. Now I can go to an organization. Let's just say, for example, it's a huge retail customer that has branches everywhere, and they want to start their decarbonization journey, and they want wind. I can give this to them in a day and show them, hey, well, you know what? Here's what this farm is going to look like for you. And here's what it's going to be. We've got it figured out because we have all the lease data. We have certain rights to some of the land. We made assumptions about the permits that we can get. It's a fantastic way to speed to market the actual product itself. So a massive difference in the ability to provide these simulations to our customers at a quick speed. And then lastly, there's always the big talk about batteries as well. I think many of us have heard, hey, somebody says, hey, I'm installing battery, or I've heard about a battery farm that's getting set up. Batteries, we have to figure out when is the right time to actually charge the battery. We simply just can't say, you know what, we're just going to charge it during peak hours. Well, usually during peak hours you can, or you got to figure out what's the load demand for the customer that has to use that particular generation coming out of that area. So what we'll do, using our algorithms here, also in conjunction with what AWS has provided us, is we are figuring out what time can we charge the battery, and also at what time can we push that capacity back out to the grid. Because there's an economic component to this, which is if I'm pushing the capacity back out to the grid, somebody has to get some of that revenue or get those attributes back to themselves. So you don't want to just push capacity back at a point in time where it's just not going to be economically feasible. They have to do it at the right time. So batteries are much trickier then, too, when it comes to pushing the capacity back out or when it's trying to charge. And sometimes people have to charge their batteries at night, in fact. Some of you might be part of organizations that have maybe 24/7 hourly matching requirements. Batteries are huge in that, especially, let's say, for example, you had solar charges during the day. You need renewable energy at night. You use your battery to push that capacity back out to the grid. And they'll use these tools to do that. So you may remember I talked about trusted data. This is how the commercial industrial side, the US economy, is moving forward for emissions reduction through trusting their data and seeing the simulations of what it's going to look like for them. So now what I'm going to do is I'm going to hand it over to Josh, because the big thing that you're probably all wondering too, especially for those of you who build a lot of these types of models, is the financial component. What does it mean from a consumption component, the rigors, the discipline that it takes? So with that, I'll pass it to Josh and allow us to take us on that journey. Thank you.
Thank you, Millen. Hello, everybody. I recognize that I am what stands between you and happy hour. Take that responsibility very seriously. Having said that, you caught me on a topic that I'm very passionate about. And you'll see that come out. If anyone knows me, you'll know I don't need to drink coffee. I'm naturally caffeinated. And so we'll have this discussion about the financial rigor that's required to run a set of platforms like we do. And hopefully you'll find it interesting and as engaging as I do. So this is a little bit of a pivot. So as you can imagine, to bring in all of the sensors, the weather data, the asset detail, all of the lat longe, everything that we're trying to do, not only for this solution, but across NextEra as a whole, it's obviously a very data-rich, intensive processing environment that we have. And one of the things that maybe sometimes gets overlooked when people do cloud migrations is they don't necessarily think about the cost. And until they get the bill. And then everybody kind of turns around and says, well, wait a minute, what am I supposed to do now? And so we've developed a lot of rigor around how to not necessarily reduce costs, but to find the right balance between performance, support, cost. The overall ability to manage your platform and your growth is really, really important. So when it comes to financial rigor, we've done a couple of different things. And quite frankly, it's not something that you do in the corner by yourself. This is something that you need a really strong partnership. And AWS has been a fantastic partner for us along the way. And while it may seem counterintuitive, their goal is not necessarily to have you spend more money. It's to be successful using their services It's to be successful building value using your systems, your data, your problem solving. And so a couple things that we wanted to talk about in terms of financial discipline is there's a few things that you can do that are straightforward that everybody really needs to think about. The first is AWS does provide out-of-the-box capabilities that you don't really need a PhD in data analytics to figure out how to use. It's the AWS Cost Explorer. It's out of the box, and it really does give you an idea just to start where you're spending money. And not only where you're spending money, but an AWS assessment of should you be, right? And if you're over-provisioned on some type of a resource or under-provisioned, or you're spending on some type of usage that really isn't necessary for what you're trying to do, they will give you those options. Now, having said that, my perspective is it takes a lot more to be really, really effective in the cloud, especially when you're dealing with data scale like we are. So in our program, we've done a variety of things to augment those capabilities. So the first one is our NextEra Cost Copilot. And I imagine everybody's heard the term copilot in a variety of different ways. Of course, within our organization, we have a dozen ourselves. And one of them is for cost management, where we're proactively reviewing on a day-by-day, resource-by-resource basis the cost spikes as compared to history, and proactively notifying ourselves and the business unit that's responsible for those resources if the cost reaches some threshold that we've previously agreed to that it shouldn't. And so if you look at the bottom left corner, the example there is actually really, really good, because what it shows you is for a particular resource, and this particular one is the cost of our S3 simple storage, right? And what you can see is on a day-by-day basis, we have a run rate that's expected. And then the cost spiked out of nowhere, and it essentially tripled completely unexpectedly. And we got notified. We worked with the business unit. We found out what went wrong, and we're able to get them to make the changes that were required to get the cost to go back to where it was supposed to be. Not because somebody was monitoring it, but because we have the proactive notifications. In this example, what we ended up with seeing is a developer, a mistake that can happen from time to time, totally by accident, where somebody had an event that was triggering another S3 bucket, which triggered the original, and it went back and forth. And you can imagine the costs just keep on going up when it says, please call my friend, please call my friend, please call my friend. It goes back and forth, right? And so those kind of things can happen, and you really have to have more of a proactive approach to figuring out how to identify those anomalies and then what you're going to do to be able to resolve them. The other thing that we've done a lot of at NextEra is we've done a lot of work around account consolidation. So as you can imagine, for a company like ours, there are a variety of different sub-accounts under our master AWS account. And that provides a lot of flexibility for us, for each of the different business units to be able to use the AWS resources as they see fit. But it also gives us a lot of optionality when it comes to the right places within our organization to actually run different workloads. And so when I say strategic account consolidation, what I really mean is there are different reasons why you might use different sub-accounts within AWS to perform certain workloads. My program is a data analytics workload. I get certain advantages based on my size and based on the commits that we have as an organization, right? And so when we think about certain workloads, it might actually make sense to use the account that I manage as opposed to somebody else's, just based on the resources I have available, the pipelines that we already have built, and the support that we already have. And that actually lowers the cost to bring that workload into AWS. And so my point is, not every workload is created equal, and where you actually run that workload can have an impact on the cost that you end up paying for running it in AWS. And then the last sort of thing that I would mention to everybody is it really does help to have a dedicated focus on FinOps or financial operations as a whole. It is a practice, it is a discipline, and it is not one that you find has a strong ending point. It's not a project, right? It's not something where you say, well, I'm going to optimize this workload, and then when I'm done, and these people can go off and do something else. It's a overarching program that you should think of in the long term. So as long as you're trying to drive value on AWS, you should have the dedicated folks in partnership with your AWS team to use the platform in the most cost-effective and, of course, highly performant way. So To make the solutions that Milan was going through and to do it cost effectively, there's obviously a look under the hood in terms of the architecture for a lot of the things that we do. So I wanted to give a quick shout out to some of the ways that we use AWS services. And quite frankly, the services have been fantastic for us over time. But one of the things you might notice is it's not all AWS native. And quite frankly, AWS is okay with that. They've been really, really good with us to help figure out what the right solution is for our workloads. And so we do a lot of things that are primarily based off of AWS services, and then where we feel it's appropriate, we do augment on top of that. And that's why we sort of think that we end up with a best in breed. And one of the great things about being in AWS and being in the cloud is you do get a lot more ability to change as tools evolve. And so if you looked at this reference architecture 5 years ago, I would tell you about half of it was different because the products were changing, the needs are changing. Obviously, Gen AI is changing how we enable some of the things that we need to do to solve some of the organizational problems, right? And I expect that to continue to evolve over time. The AWS team that we work with has been great, not only in terms of helping us figure out what to do and put the slideware together in terms of our reference architecture, but to actually do the proof of concepts, to actually show it in action, to show it at scale, to show the cost, right? Because as you can probably tell from the cost perspective for me is really, really important. And so when we talk to AWS and we say, well, that sounds really wonderful. I know you can do all these things. You're the best things since sliced bread and Doritos. However, I need to prove that it actually works at scale and cost effectively, and they work with us to make sure that it actually happens before we end up moving that workload. So it's really a great partnership. So a couple of the other things that I kind of wanted to point out in terms of how we use data and how we use AWS in this sort of way at NextEra is to sort of think about AWS not only as the enabling platform, but really as a partner. And it might sound cliche, but the truth is it's really the way that we organize ourselves at the company, because we don't go into the cloud journey expecting we know every answer to every question, and we use AWS to help us along the way. So I wanted to highlight a couple of the ways that you might consider thinking about leveraging your own relationship with your AWS team. So the first is around consulting and best practices. Notice it's not AWS best practices, it's just general best practices for the type of workload that you want to run. And they do provide a lot of support for that. There's a lot of work around governance, which can also be overlooked from time to time. And we're very fortunate to have a team that recognizes the importance of having strong governance capabilities within your solution. FinOps and financial management is one of them, of course, right? Some of the access controls and cybersecurity considerations, those things and the governance associated are really, really important. And then on the bottom left, the leveraging the partner ecosystem. As I said earlier, we don't really know the answer to every problem that might be coming up. And sometimes AWS doesn't either, but I bet they have a client who's doing something really similar. Right? And that's one of the great advantages of having the partnership with AWS is sometimes we just go in and say, look, we want to move 81 billion data points per day from our sensor data out in the field for all these different assets, and we want to do these crazy things with them. We want to make it happen instantly and totally for free. Show me who's done it. And they help us find as close of a partner as possible to that type of use case. So I highly recommend using the relationship with AWS to help make the connection to those who might be able to help you from some of their own experiences. Also, from new services and testing, I can tell you some of the products that AWS has offered over the years have been improving significantly in terms of the performance, in the ease of use, in some of the way that you manage the access, and sort of making the experience of developing in AWS a lot easier. And so I definitely want to make that a shout out. I also say that because it's important that you recognize the level of maturity of the AWS service that you're using, because sometimes something right out of the box is straightforward enough and you can make it make use of it. And then sometimes you have to push the product to maybe sort of close to the edge of what it was intended to do. And that's actually a really good use case for AWS to hear about, because that's how the products continue to improve. And we've seen that relationship with AWS where we can tell them some of the things we're trying to do, and then the services evolve over time, and then we see some of those new features start to come through. So I can tell you with examples that I would love to talk to all of you about afterwards in terms of the things that they've done to improve the products and make it easier for all of us to use over time. And of course, I think I've beat the dead horse with cost management. There is a lot of capabilities out of the box, and they have a lot of support guidance for how to get to AWS in the cloud so that nobody feels like it's a burden and nobody feels like it's this overly cumbersome task. So if we kind of broaden ourselves past the battery and solar and wind generation, from an enterprise data perspective, there's a lot going on in our organization using the same reference architecture, using the same capabilities that we were describing earlier. And so I wanted to kind of highlight some of the really good work that's being done. So the first is we have a lot of things in the clean energy solution space just generally, and that's for commercial and industrial customers to municipalities around the country and a variety of other initiatives to help decarbonize pretty much everyone, including ourselves, right? And to make that happen, as you can imagine, a lot of data and a lot of reusable data. And that's one of the great things about the job that I have, which is being able to tell somebody, hey, I've already got this, it's secured, it's governed, it's available, it's performant, and it's already available, so we can just go, right? And that's a really fun part of my job when we get to do that. Kind of moving into the middle tier, we have the drones. So there's a growing use of unstructured data at the organization, including videos, imaging, of course, some audio and other unstructured data sets to drive different types of value that we want to drive. And the drone program that we have is actually pretty substantial, a lot of images. As you can imagine, in Florida, hurricane central of the United States, we do get a little storm from time to time. And when that happens, we have to deploy a massive number of resources, trucks, parts, a lot of labor to be able to restore service to our nearly 6 million customers at FPL as fast as humanly possible. And we use drones to help us identify the areas where we have damage that we need to spend the most time trying to get restoration efforts. And so as those images are streamed from our drones into our platform, we get to use that real time to drive the decisions regarding where we're going to send trucks, right? The weather impact cannot be underestimated. I would say every business unit within the organization relies on really good weather data and really good weather predictions to run their business. AWS has actually been a really great partner with us on this journey because they also, for their delivery, for their warehouse management, they also rely on weather a lot. So we've been able to build that partnership. We collect a lot of data and we try to create simple, reusable KPIs so that everybody is working off of the same sheet when it comes to our weather data. From a customer perspective, fraud, unfortunately, is still a part of our business that we have to pay very close attention to. And so we use a lot of customer data and what we call behind-the-meter information to help identify anomalies that may or may not be something fraudulent that's occurring. That happens not only on the FPL side of the business, but all across the customer domain where we have on the C&I customers and some of our Texas business as well, where we're really using a lot of the AWS horsepower to help churn through models to identify potential fraudulent activities for us to go after. And what I'll tell you is the savings are incredible. They more than pay for the cost that we pay to AWS for using their services. So as we kind of finish up and get everybody ready for happy hour, I just want to thank you for the opportunity and say decarbonization is everyone's legacy, and it does require collaboration. So the ask from us to you is, how will you leverage data and analytics to reach your goals? Thank you.